Imagine staring up at a perfectly ordinary sky, and then, in an instant, the sun simply blinks out of existence. No flash, no warning, just gone. What would actually happen to Earth, to the moon, to you in the minutes, days, and years that follow? The answer is stranger and far more unsettling than you might expect. Here's the first twist. For about 8 minutes, absolutely nothing would seem wrong. Sunlight takes roughly 8 minutes and 20 seconds to travel the 93 million miles from the sun to Earth. So even after the sun vanished, you'd still be standing in daylight, feeling its warmth on your skin. In fact, you're always looking into the past whenever you look at the sun, or any star, in the sky. If a distant star died tonight, its light would keep shining for us for years, decades, or even centuries before anyone on Earth ever noticed. Right now, you might be looking at ghosts of light. Gravity plays by the exact same rules. According to Einstein's general relativity, changes in gravity also travel at the speed of light, never instantly. So Earth would keep calmly orbiting an empty point in space, tracing its usual path for those same 8 minutes, completely unaware that anything had changed. Then, the moment finally arrives. The last photons and the last gravitational tug reach Earth at precisely the same instant, and everything breaks at once. The sky above you would snap to black, as if someone had thrown a switch, because there is no more light coming from that direction ever again. At that exact same moment, gravity's pull would disappear too. Without the sun's gravity holding it on a curved path, Earth would stop orbiting and fly off in a straight line. This obeys Newton's simplest law. An object in motion stays in motion unless something stops it. Earth's orbital speed is about 67,000 miles per hour, and that speed wouldn't vanish along with the sun. It would simply stop curving. Our planet would go drifting in a straight line into the darkness of interstellar space, forever, carrying every one of us along for the ride. You wouldn't feel a jolt or a lurch or anything at all. There's no sudden stop, no crash. Gravity just quietly releases its grip. Earth continues moving in whatever direction it happened to be heading at that instant, the way a ball keeps rolling after you let go of its string. The moon, though, would still be right there, still orbiting Earth, because Earth's own gravity never went anywhere. The two of you, planet and moon, would now travel together through the void. A small, orbiting pair. Adrift, no longer anchored to anything at all. Meanwhile, every other planet in the solar system would go through the exact same unraveling, just at slightly different times. Light and gravity take longer to reach Mars or Jupiter or Neptune, simply because they sit farther away. One by one, each planet would peel off its orbit and sail into its own straight line. The solar system, as we've always known, it would simply cease to exist, scattering into the dark like marbles rolling off a table. But the sky going dark is only the beginning of the real disaster here on Earth. That's not even the strangest part of what happens next. Without sunlight, photosynthesis, the process plants use to turn light into food, would stop almost immediately. Most plant life on land, and in the sunlit layers of the ocean, would begin dying within days. And that's just the first domino in a much longer chain of collapse. Within weeks, the animals that eat those plants would begin starving too, and the collapse would ripple upward through every ecosystem on the planet. Ocean surface waters, normally teeming with microscopic phytoplankton, would turn dark and lifeless in a similar cascade. Entire food chains would begin folding in on themselves. Temperature, surprisingly, is where things get grim, more slowly than you'd expect. The oceans hold an enormous amount of stored heat, acting like a giant thermal battery for the whole planet. Even so, estimates suggest global surface temperatures could drop below freezing within about a week. Within a year or so, the oceans would begin freezing over, starting at the surface and slowly working downward. Ice floats, and it insulates the water beneath it, which turns out to be a strange stroke of luck. Liquid water might persist deep under that ice for a very long time, warmed faintly by heat left over from Earth's core. Above the ice, though, the surface world would become a frozen wasteland almost beyond imagining. Without the sun's energy driving global weather, winds and storms would gradually die down entirely. The atmosphere itself would start to change in ways that are almost too strange to picture. As temperatures kept falling, eventually plunging toward hundreds of degrees below zero, the very air we breathe would begin to liquefy, then freeze completely. Nitrogen and oxygen, the main gases in our atmosphere, would fall from the sky as snow, blanketing the frozen ground in white. Could anyone actually survive this? Surprisingly, yes, for a while, at least. Humans have access to nuclear power and geothermal energy, heat sources that never depended on the sun in the first place. Underground shelters or carefully engineered greenhouses could theoretically sustain small pockets of human life for a long time. Even on the surface, small groups might endure for a while using stockpiled fuel, insulated shelters, and artificial grow lights for food. But without an entire planet's food and energy systems running normally, civilization as we currently know it simply could not continue indefinitely. Some scientists point to deep-sea ecosystems clustered around hydrothermal vents, far below the ocean's eventual frozen surface. Those communities don't rely on sunlight at all. They run on chemical energy, seeping up from the Earth itself. The strange worms and bacteria living there might barely notice the sun was ever gone. Here's the part that puts everything into perspective. This scenario is already playing out across our galaxy, minus the sudden disappearance. Astronomers have discovered rogue planets, worlds with no star at all, drifting alone through interstellar space, dark and cold, orbiting nothing. Some of these free-floating planet-sized objects have masses similar to Jupiter, yet no star to call home at all. A few may have formed alone in the darkness, never orbiting anything, born as orphans from the very beginning. Others were likely kicked out of their own solar systems entirely, flung loose by gravitational encounters with other planets. They went tumbling off into the void, just like Earth would in this thought experiment. It's a quiet, haunting reminder that being anchored to a star is never guaranteed. It's a gift. Now here's the thing this whole scenario actually reveals. The sun can't really just vanish. Doing so would break one of physics' deepest rules, the conservation of mass and energy. Mass and energy don't simply disappear from the universe. They only ever change form. So this what if is a pure thought experiment, a tool for exploring how gravity, light, and energy truly behave. It's less a prediction and more a scientific funhouse mirror. It reveals the real mechanics of our solar system by removing one piece and watching everything else unravel. The sun's actual fate, billions of years from now, will look nothing like this sudden vanishing act. It will slowly swell into a red giant, gently on cosmic timescales, engulfing the innermost planets in its expanding outer layers. Then it will shrink down into a white dwarf, a small, dense ember, fading over almost unimaginable stretches of time. No sudden darkness, no cosmic light switch flipping off, just an ancient, gradual ending written across billions of years. It's worth remembering that Earth itself will likely be scorched or even swallowed during that red giant phase, long after humans are gone or evolved into something else entirely. That's billions of years away. Plenty of time, cosmically speaking, to worry about almost anything else first. And maybe that's the real wonder tucked inside this impossible scenario. Every single day, an enormous, ongoing nuclear furnace 93 million miles away is quietly keeping you alive, holding your entire planet on its gravitational leash. Every plant that grows, every gust of wind, every drop of rain falling from the sky depends one way or another on that one furnace in the sky. Nothing about that arrangement was inevitable. It's simply the quiet backdrop to absolutely everything you've ever known. It's easy to take a burning ball of gas for granted when it's risen over the horizon every single morning of your life. But nothing about that steady, reliable light is guaranteed by the universe at large. It's a fragile, fortunate arrangement of physics, gravity, and time. If this kind of question gets your brain buzzing, if you love imagining the universe breaking its own rules just to reveal how it actually works, this channel is built for exactly that kind of curiosity. Consider subscribing and join us as we keep asking what if about the strange, beautiful cosmos we call home.